Alrighty, hello everyone. Happy Halloween. Unfortunately, I'm not able to be there today. I came home and felt pretty terrible, but luckily we got through most of what we needed to talk about yesterday. So actually I'm just gonna recap and then we're gonna finish off example 4. You guys will have a check your understanding and then you'll be able to work on the things. So just a reminder of what we talked about yesterday, in case you missed it, is we started section 9.4, fixed and variable expenses. And the goal of today's lesson was to explain the difference between a fixed and a variable expense, and then create an equation based on these two new things, fixed and variable expenses. So we started off graphing two different lines using y equals mx plus b, and we took this opportunity to review, where does the slope? It's in front of the x. Where's the y-intercept? It's chilling on the outside. Using the slope and the y-intercept to graph two lines, and then where the lines intersect or where they meet, oftentimes that can be called the equilibrium value, or it could be called the break even, kind of just depending on what your kind of graphs are looking for. And so we started thinking about, if we were going to manufacture things, what type of expenses are involved with that. And we started talking about these art students, and they're going to make hand-painted t-shirts. They're going to make hand-painted whatever. They're going into business. They're going to mass produce it. So what are the things that they're going to need to run this business? They're going to need some factory space. They're probably going to need some furniture in their office. They're going to need some sort of delivery trucks to deliver the things that they have. Either the supplies or actually delivering the products. They're going to need electricity for this space. They're going to need a phone and a computer and some office supplies so that they can conduct business. But then they're also going to need all the supplies that is going to help them actually produce their hand-painted amazingness. They're going to need t-shirts, they're going to need paint, they're going to need a bunch of other things. You guys brought up some great ideas of plastic holders for the paint. They're going to need paint brushes. They're probably going to need some sort of sealant for the fabric, things like that. You got the right idea. But ultimately, t-shirts, paint, packaging, postage, labor. And let me tell you, this stuff ain't cheap. So everything that these art students are going to need can be put into variable expenses or fixed expenses. Variable is where the cost varies based on the number of items produced. So for example, if you're only producing one t-shirt versus 100, that's a whole different amount of paint, right? That changes based on how many items that you're producing. Versus your telephone bill, that's not going to change at all. It's a fixed expense. Maybe it's $100 a month. That's not going to change whether you produce 0 items or you produce 1,000 items. So we can put these expenses into 2 separate categories. And to calculate the total expenses for our expense function, we would just add the variable values plus the fixed expenses. Revenue is the income you get from selling your product. The revenue function is when you multiply a price times the number of things that you are selling, your quantity. And so that will tell you how much your business is getting from income. If we want to figure out if we have a profit or a loss, we'll do our revenue and subtract our expenses. And if it's positive, that's profit. Or if it's negative, that's a loss. And oftentimes we want to know when we're breaking even. We're neither in a profit nor a loss. So that's when the expenses and the revenue are equal to each other. That would be when R minus E is equal to 0. So we started going through some examples. We were like, hey, the art students have researched all expenses and they think it's going to be $17,600. That's a lot. And the labor and materials for each pair of painted jeans or painted shirts or whatever they're painting is $7.53. So we wanted to figure out the total expenses E as a function with quantity produced Q. So right now, E was in terms of F and V, and we want it to have just the variable Q. So we said the total expenses E is equal to the variable cost plus the fixed cost, substituted in the variable and the fixed cost, and boom, we got 7.53Q plus 17,600. one thing you guys just needed to do was to check your understanding. So it's just a little bit of algebra of the same type of idea. If an expense function E is equal to 6.00Q plus 11,000, what is the cost to produce one widget? So we remember that the total cost E is equal to the variable cost plus the fixed cost. And the variable costs are 6 times Q, $6 per each quantity. So we kind of just really needed to know where to look. If we're only going to produce one quantity, one widget, how much does that cost us? That variable cost is $6. Then we said, hey man, these people are going to manufacture the Kavetsky ski supply. They're going to manufacture hand warmers, and their expense function is 1.18Q plus 12,000. If we wanted to find the average cost of producing hand warmers, if we produce 50,000, we first needed to set up our total expense function as it's given to us, replace the quantity with the 50,000 that we're going to make, and simplify that. We ended up getting our expenses equal to 71,000. So now to figure out on average how much that costs, take the amount that we just found, 71,000, and divide it by the quantity, 50,000 pieces. Right? 71,000 divided by 50,000, that gives us $1.42 on average for each hand warmer when we produce 50,000. Your checking your understanding is the same thing. You're taking the expense equation, 3.40, there was a typo there, it should be Q, plus 189,000, and dividing it by the number of items, the quantity that we have, like part 2, this ratio, the dollar amount that we get after we plug in Q divided by the quantity. So we'll just leave it this algebraic way. Example 3 says Willie's Widgets has created a demand function where Q is the quantity and P is the price. And so the quantity is equal to negative 112P plus 4,500. If the expense function is 3.00Q plus 18,000, again, this is just expressing expense as a function in terms of P. The expense function is E. That's equal to the variable times the fixed, the variable plus the fixed, and so we actually already had that equation, and instead of Q, just leaving it as Q, we can plug in the quantity of the widgets given above. Distribute 3 times negative 112 gives negative 336. 3 times 4,500, take that number and add it to 18,000, you get 31,500. Check your understanding is pretty similar. We take the total expense function, which is 4.00Q plus 78,000, and our goal is to rewrite that in terms of P. So replace Q with negative 4P plus 3,000 because that was given in the equation. Distribute and combine your like terms. You'll get your expense function is equal to negative 16P plus 90,000. And we ended on this problem in class. So this is where we're picking up where we left off. So Wally's Widget World created a monthly expense function E equals 1.10Q plus 42,000. Sorry, 4,200. So this one was already given to us. Like E is straight up just given to us in the problem. Okay. Then something a little tricky is we have to write the revenue in terms of what comes next. It says that Wally's Widget World plans to sell its widgets to retailers at the wholesale price of $2.50 each. So that means $2.50 times every quantity is the revenue, right? The price times the price times the quantity, that's the revenue, right? So our goal is to figure out how many widgets must be sold to reach the break-even point. So part 1 is we're going to plot both equations. So when we just came up with revenue is equal to the price times the quantity, and it told us the price was $2.50. That was an equation we had to come up with ourselves, and also the one that was already given to us, E. 1.10Q plus 4,200. Now, something to keep in mind here is when we're graphing, we're starting off with quantity on the x-axis. This is going to be quantity Q. And on the y-axis, we're going to have the dollar amount up here. Okay, a little different normally instead of X and Y, but what's interesting is you can actually, even though we have Q and in each of our equations, it will actually graph it just the same on Desmos. So we'll pull up Desmos and we're going to put R equals 250Q and E equals 1.10Q plus 4,200. Okay, then we're going to zoom out until we find the intersection point and look for the coordinates. That is the break even. That is when the revenue is equal to the same amount as the expenses. So here's Desmos. You can see my first equation, my revenue equation, my price, $2.50 times my quantity is right here. That one's graphed in red, or I'll just highlight it. Boom. I let Desmos do it for me. And the equation that was given to me already was my total expense function, 1.10 times Q plus 4,200. That's right here. So I graphed them. It worked out just fine. I ended up... What the heck? Whoa. My bad. Sorry. I don't know what just happened on my thing. I ended up finding the intersection point, which is located right here, and that's going to be the break-even point. We have 3,000, 7,500. Remember, along the x-axis was the quantity Q. So this is Q, and the Y value is the dollar amount. So that means that when we produce 3,000 widgets, or in this case, the company is planning, it doesn't even tell us what the widget is, right? If we sell 3,000 widgets, it's going to cost us $7,500 to produce it. There's no profit. This is when the revenue R is equal to E. Those are the same. They're sharing that same intersection point. All right. There's no profit here. So it's just like interpreting where the graphs are breaking even, where they are equal to one another. So one thing that you'll want to notice, and this is like new, this isn't going to show up on Desmos or anything like that, but anytime that the that we're in the green area, that means that our revenue function, which we started off graphing in green, like if you remember what it looked like originally on our first one, right? That was this one over here. It started at 0. Whenever the revenue function, okay, right here, that guy's the revenue. That's my revenue function. To start, it is below the expenses. We can see that like the green little part is literally below the yellow line, right? The yellow line is above, it's above, it's above, and then finally they're equal to each other right here. Then the green function is above, right? From our break-even point on out, right? They're equal right here. And then as we move to the right, the revenue, it's on top. It's literally above. That means that we're making more revenue than expenses. So you can see that the graph is shaded in green, right? This green area is where literally the revenue function is above the expenses. It's where the revenue, the money we're making from our business, is bigger than the actual expenses it costs to like run our business. And so obviously this is what happens when we get a positive. When we do revenue minus our expenses, if it's a positive number, then we have a profit. So anywhere in the green area to the right of the break-even point is going to be a profit, because that's when the revenue is literally bigger then I'm going to put BE for break even, but you can see that revenue is larger than your expense function, right? Everywhere to the right. Similarly, on the left, you can see the red shaded area. That's where, on the left-hand side, the expense is bigger than the revenue function, right? The yellow line is up higher than the green. It's a little hard to see the green, but I'll help us out. It is right here. It's right there. Where the expenses are larger than the revenue, meaning that the expenses that we have for the business are greater than the amount of money that we're making. Obviously, that's going to be a bad thing. This area right here is going to result in a loss, meaning we're not making any money. Whenever your revenue minus your expenses is equal to a negative number, that's when we're going to face a loss. Or whenever the expenses are bigger than those revenues, right, we're going to face a loss. So this is just like a nice little graphical representation. I can say the same thing for whenever revenue minus expenses is equal to a positive number. That's going to give us a profit. So this question really was just asking how many widgets to be sold to the break-even point, and then we spent a little bit of time like interpreting these two graphs. So up to you is if the company sells 2,900 widgets, is Wally Worlds operating above or below that break-even point? What's the difference between the revenue and the expense? So let's do a little graphical interpretation again. We've got our y-axis, we've got our x-axis. If we look back, the x-axis was our quantity, Q, and the y-axis is usually money. Yep, dollars. Okay, we started off with our revenue function, R, and then we went into our expenses function, which was just a little bit higher, and it, went like this. Okay, that was our revenue, that was our expenses. Our break-even point was where they were equal, and we looked down to figure out what that quantity was, and that was 3,000. And the price ended up being 7,500. Oops. Excuse me. Okay. So it says if the company sells 29,000 widgets, the quantity is 29. That means it's going to be to the left of 3,000. 2,900. Sorry, I said 29,000. If they sell 2,900 widgets, is this above or below the break-even point? Well, that's going to be below, because 2,900. Oh my goodness, this is so messy. I apologize. Because 2,900 is smaller than the break-even point of 3,000. So it's definitely below the break-even point, which is a bummer, meaning that we are in the red. Right here at 2,900, we are in the red zone, which means we are facing a loss right now. If we produce less than the break-even amount, then we are in the loss. So if we were going to figure out what is the difference between the revenue and the expense, we would have to go to like what the revenue value is right here, and get that y coordinate, and then similarly go to the expense and do the subtraction, and you'll see that you get a negative number, which is why we're in the middle of the loss. So we're going to need Desmos for this. Remember how last time we punched in 250Q and 1.10Q plus 4200? It's that same thing. So what we're going to do is we're going to go and I'm going to show you how we can just straight up go over to Desmos and use this to our advantage. desmos.com. And then we're going to do a graphing calculator. And then you're going to type in our revenue equation and also our expense equation. I don't remember what they are, but I can go back and look. Revenue was 250Q, $2.50. So R is 2.50Q. And we got it. And our expense function was going to be 1.10Q plus 4200. 1.10Q. 1.10Q plus 4200. Okay. This is what I mean. You'd have to like type it in and then you'd have to zoom out on Desmos. And eventually there's two of the lines, right? And so this is what I did. I just touched the graph and you can see where they are equal to one another. That is the break-even point right here. But I'm not interested in the break-even point anymore. I'm interested when my quantity is equal to 2,900. I know that that is less, right? So 20, when X is 2,900, that's like my X axis, but it doesn't know what Q that. It knows what Q is on my equation, but it doesn't know it when I'm actually like zoomed into Desmos, which is a little annoying. So we'll just write X. And so, even though it's like on the X axis, here we can like zoom in and figure out what is the revenue when X is 2,900. When the quantity is 2,900, we can see that on our red graph, the revenue is 7,250. So if we go back, 7,250 is where we at. So our revenue is equal to 7,250. So we will say R is equal to 7,250 when our quantity is 2,900. And now we need to figure out what is the expense. We're going to subtract those two, right? So we're still using the 2,900. The X value is 2,900, or Q, the quantity, is 2,900. So we're going to look back at Desmos again. Pull it up, and we see, oh, here it is. So when X is 2,900, the expenses is 7,390. We can see if we're only making 7,250, but it costs 7,390. We're in the red, man. The expenses are $7,390. It's on the blue graph. The blue graph represents the expenses, 7,390. So my expenses are 7,390. We can see that when we do the revenue minus the expenses, 7,250 minus 7,390, that is going to be a negative number, right? 7,250 minus 7,390. That's going to give us negative $140. This is a loss. Numerically, this makes sense. Graphically, this makes sense. When we are less than the break-even point, then we are going to be having a loss. How much is the loss? It's $140. That's crazy. So, example 5 says find the solution to example 4 algebraically. So, the solution to example 4 was how many widgets must be sold to reach the break-even point. If we look at this graph, the break-even is when the expense is equal to the revenue, right? When the revenue function is equal to the expense. So if I wanted to do the same thing here, if I want to find the break-even, this is when they are equal to one another. So I'm going to set the revenue function, 250Q, equal to the expense function, 1.10Q plus 4,200. And the goal is to get Q alone. Solve for Q. Pretend Q is X, whatever you gotta do. But we're gonna move things to one side and then isolate it. So we've got positive 1.110 on the right. If I take away 110Q on both sides, I'm allowed to do that. That would leave me with $140Q is equal to 4,200. If I want to get Q alone, I just need to divide by 140. That would leave me with just Q. And 4,200 divided by $1.40 or 1.4 gives me 3,000. And if we look back at the break-even point, remember the x coordinate was 3,000. Right? If we look back over here, the x coordinate was 3,000. Right here, that's the x coordinate. That was 3,000. When we look on Desmos, the x coordinate, or Q, the quantity, was 3,000. Boom. We got it. If we want to make sure we also get the y value, you just need to plug x into either the revenue or the expense function. So, honestly, it's a little easier to plug it into the revenue, but like you do you. If I want to find the y and make sure it actually matches, I could plug it in to 2.50, and then I'll just plug in my quantity that we just got. Again, you can plug it into either. This is just the simpler one. And if you do 250 times 3,000, 2.5 times 3,000, you will get 7,500, which is the y value that matches. And remember, revenue, that's money, dude. And if we look back at the y-axis, dollars was on the y. We got 7,500, we got 3,000. Life is good. Check your understanding. Find the break-even point for these two functions. We've got the expenses is 5.00Q plus 60,000, and revenue is 7.00Q. If we want to find the break-even point, that means we have to set them equal, right? Maybe I set my expense function equal to my revenue function, which means this is 7.00Q if I just substitute it in. This one is 5.00Q plus, oh man, I ran out of space. Let me fix it. 5.00Q plus 60,000. And again, it's the same idea. You want to get Q alone. The one with the smallest one is 5, so it's positive 5. If I just take away 5.00Q and take away 5.00Q, then I've got 60,000 equals 2.00Q. To get Q alone, whoa! Maybe later. I don't know what's going on there. Get out of here, man. I'm just going to divide both sides by 2.0. Oops. And I will get Q is equal to 30,000. Boom. This took a little longer than anticipated, but I did do a quick little review, which is nice. So now that we are finished, you guys have some workbook problems to do. Quick reminder, this was a video that I'm uploading to you guys because I don't feel great, and I have a fever. and all that good stuff. So with this video, remember you can pause, rewind, change the playback speed, whatever you need, whatever floats your boat. But these workbook problems, it is going to be due tomorrow, November 1st at 11:59 p.m. I hope you guys have a great day, and I hope you have a happy Halloween.